This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today, we're diving into an interactive learning tool that's revolutionizing how students grasp complex physics concepts, the Periodic Orbit's JavaScript simulation applet. It's a fascinating piece of educational software.
Indeed, it's a testament to how technology can make abstract ideas like orbital mechanics much more accessible and engaging for learners.
The applet allows users to manipulate parameters and observe the resulting orbital behavior in real time. What's the most impactful aspect of this interactivity, in your opinion?
But the ability to directly manipulate the initial conditions, students can drag the spheres, change the time step, and see the immediate effect on the orbit. This hands-on approach fosters a deeper understanding than passive observation.
Exactly. It's not just about watching a pre-programmed animation, it's about experimenting and discovering the underlying principles. Let's start with the overview. The applet is part of the Open Educational Resources / Open Source Physics at Singapore project. What are the key benefits of making this resource open and accessible?
Open access democratizes education. It removes financial barriers, allowing students worldwide to benefit from this interactive learning tool. The open source nature also encourages collaboration and improvement from the wider community.
And it's built using HTML5 and JavaScript, ensuring cross-platform compatibility. This is crucial for accessibility, isn't it?
Absolutely. It means students can access it on any device with a web browser, regardless of operating system or location. No need for specialized software or plugins.
The applet boasts several key features. You mentioned the draggable spheres. Can you elaborate on the significance of this feature?
The draggable spheres allow students to explore the impact of initial conditions on orbital paths. They can change the starting positions and velocities of the celestial bodies and observe how these changes affect the resulting orbits. This is a powerful way to visualize Kepler's laws and Newtonian mechanics.
And the zooming functionality, how does that enhance the learning experience?
Zooming allows students to examine the orbits at different scales. They can zoom in to see fine details of the orbital path, or zoom out to get a broader perspective of the overall system. This flexibility is essential for understanding the nuances of orbital mechanics.
The applet also includes controls like play/pause, step and reset buttons, and editable fields for parameters like dt, toll, and n. What role do these play in the learning process?
These controls provide granular control over the simulation. Students can adjust the time step to slow down or speed up the simulation, change the tolerance, toll, to adjust the accuracy of the calculations, and modify the number of steps, n, to control the simulation's duration. This allows for a more in-depth exploration of the system's behavior.
The applet credits Juan M. Agurgaviria, Fremont Tang, and Lateng. What does this collaborative effort signify?
It highlights the power of collaborative development in creating high-quality educational resources. Different individuals bring unique skills and perspectives, leading to a richer and more robust final product.
The resource is licensed under the Creative Commons Attribution Share Alike 4.0 Singapore license. What does this mean for users?
It means the applet can be freely used, adapted, and shared, provided proper attribution is given. This fosters a culture of open sharing and collaboration within the educational community. However, commercial use of the underlying easy JavaScript simulations library requires separate licensing.
The applet has numerous potential uses. How can teachers effectively integrate it into their classroom instruction?
It's ideal for classroom demonstrations, allowing teachers to visually illustrate complex concepts. Students can also use it for independent exploration, conducting virtual experiments, and testing hypotheses. It's also well-suited for homework assignments and online learning modules.
Beyond the classroom, are there other potential applications?
Absolutely. The applet's embeddable nature makes it suitable for integration into online learning platforms and websites. It can also be used for self-directed learning by students outside of formal educational settings.
The accompanying study guide includes a quiz to reinforce learning. What are some key concepts the quiz assesses?
The quiz covers understanding periodic orbits, gravitational interactions, simulation parameters, and the applet's interactive features. It aims to ensure students have grasped the core concepts and can effectively use the simulation tool.
And the answer key provides immediate feedback, right?
Yes, the answer key allows students to check their understanding and identify areas where they might need further review. This immediate feedback loop is crucial for effective learning.
The study guide also includes essay questions. What kind of critical thinking skills do these questions promote?
The essay questions encourage students to analyze the simulation's pedagogical value, discuss the significance of adjustable parameters, and consider the benefits and drawbacks of using simulations in education. This promotes higher-order thinking skills and deeper understanding.
The glossary of key terms is also a valuable resource. Why is it important to define these terms clearly?
A clear definition of key terms ensures that students understand the terminology used in the simulation and the accompanying materials. This is essential for avoiding confusion and promoting accurate understanding of the concepts.
The document outlines sample learning goals, though they aren't explicitly stated. What are some likely learning objectives for using this applet?
Likely learn objectives include understanding periodic orbits, gravitational forces, and the relationship between initial conditions and orbital paths. Students should also learn to interpret simulation parameters and use the applet's interactive features effectively.
The instructions are straightforward. What makes them effective?
The instructions are clear, concise, and easy to follow. They provide step-by-step guidance on how to use the applet's features, making it accessible to users of all levels.
The FAQ section addresses common questions. What are some of the most frequently asked questions about the applet?
Common questions include how to access and embed the applet, its key features, learning goals, creators, and commercial use licensing. The FAQ section provides comprehensive answers to these questions, ensuring users have the information they need.
The FAQ also clarifies the licensing for commercial use, which is important for transparency.
Precisely. It ensures users understand the terms of use and avoid any potential legal issues.
The website lists many other related simulations. What does this extensive collection suggest about the project's scope?
The wide range of simulations demonstrates the project's commitment to providing comprehensive and diverse educational resources in various scientific fields. It shows a dedication to creating a rich and interactive learning environment.
The website also displays statistics like the number of online users and article views. What is the significance of this data?
This data provides valuable insights into the website's reach and impact. It shows how many people are using the resources and how popular they are, which can inform future development and improvement efforts.
In summary, the Periodic Orbit's JavaScript simulation applet is a powerful tool for teaching and learning about orbital mechanics. What makes it stand out from traditional methods?
Its interactive nature allows for hands-on exploration and experimentation, fostering a deeper understanding than passive learning. The open-source nature and cross-platform compatibility ensure accessibility for a wide audience.
And what are some of the key takeaways for educators considering using this resource?
Educators should consider the applet's potential to enhance student engagement, promote deeper understanding of complex concepts, and facilitate independent learning. The open-source nature allows for customization and integration into existing curricula.
The applet's success lies in its ability to bridge the gap between abstract theory and practical application.
Precisely. It transforms a potentially challenging topic into an engaging and interactive learning experience. The combination of interactive elements, open access, and a well-structured study guide makes this a truly valuable resource for physics education.
That was a great discussion. Thank you for your insights.